Okay, so the equation for an absolute value function is y equals a absolute value bar x minus h, close your absolute value bars, plus k. We know that the vertex is determined by the h and k values, and we know that the a value determines if the absolute value function opens up or down, meaning if it opens up, it would have a minimum. If it opens down, it would have a maximum. It also tells us the slope of the branches of the absolute value function. Okay, when I say slope, I'm talking about the slope of this right-hand side and the slope of the left-hand side. So, using this information, the first thing we're going to practice doing is finding the vertex. The first place I look for the x value of the vertex is inside the absolute value bars. If I don't see a value there, that tells me that the x value of the vertex is 0. The y value of the vertex corresponds with the k term in the formula. Because the formula has a positive k value, you can take the sign exactly as it looks in the equation. So if it looks like a positive 4, we can leave it as a positive 4. The axis of symmetry, just like in a quadratic or a U-shape, is the equation of the line that passes through the vertex that would allow you to fold the absolute value function onto itself and it would match. So the axis of symmetry is x equals the x value of the vertex. In the next one, again, we want to look on the inside of the absolute value bars to determine what the x value of the vertex is. In this case, because the formula has a minus here, if we see a positive 4, our x value of our vertex is actually negative 4, but we can keep the sign of the negative 7. So I like to say the x value of the vertex has to have a switch sign, so switch what you see on the h and keep what you see for the k. X of symmetry would be x equals negative 4. The next one, it looks like a negative 2, so our h value would be a positive 2, the x value of the vertex, and then the positive 5 stays. The x of symmetry is x equals 2. Keep in mind that the x of symmetry will always match the x value of the vertex. Okay. Down here, we want to determine, using the a value, the value in front of the absolute value bars, if the absolute value function is going to open up or down, and what the slope of the branches are. So because the a value here is positive, if the a value is positive, the v is going to open up. If the a value is negative, the v is going to open down. Because this a value is positive, the absolute value function opens up, which means its vertex is a minimum. Because the a value is 2, the slope of the branches are 2 on one side, but since the other side has a negative slope, it's 2 and negative 2 on the other side. For this one, because we have a negative a value, the a value is negative 1/2, that means the absolute value function opens down, which gives you a vertex that is a maximum. And the slope of the branches would be negative 1/2 and also positive 1/2. The last one here, the a value is negative 1. Even though you don't see a number there, we assume that there's a 1. So negative 1, which means the absolute value function opens down and has a maximum. The slope of the branches would be negative 1 and positive 1. This all helps you when we go to graph an absolute value function, because those are really the only things we need to know. If we know the vertex, the way that the absolute value function opens, and the slope of the branches, we can easily graph it. So first we're going to look for the x value of the vertex and the y value of the vertex, and then we're going to look for the a value. So the x value of the vertex would line up here. Remember, this is usually x minus h. So it looks like a -2. That means my x value of my vertex is going to be +2. And I keep the sign that's on the k value, which is 1. So my vertex is at 2, 1. I'll go to 2, 1 and plot my first point. My axis of symmetry is x equals 2. If it helps you to put a dotted line here where the axis of symmetry is, that reminds you that this is the center of your absolute value graph. So you need to have a portion of the graph on both sides of that line. The direction of opening. Since the a value is 3, the number that's in front of the absolute value bars, we have an absolute value function that opens up, which means that it has a minimum. And we're going to need to use our slope of the branches, which is the value of the a value in the formula. So we're going to use 3. We're also going to use -3. From this vertex, we know that this absolute value function is going to open up, so we're going to start counting up 3 and to the right 1 and put a point. On the other side, we're also going to count up 3, but we'll go left 1. You can see that these two values are symmetric across this axis of symmetry. So they're both 1 away from the absolute, or from the axis of symmetry. Okay, let's try one more here. Our x value of our vertex in the next example is 0, because I don't see anything with the x in the absolute value bars. The y value is 4. My a value in front is -1/2. So if a is -1/2, that means that my absolute value function is opening down. It has a maximum. And the slope of the branches are -1/2 and +1/2. Okay, my axis of symmetry would be x equals 0. So I'm going to go to 0, 4, plot a point. Here's my axis of symmetry. The slope of the branches are -1/2 and +1/2. So from this point, I'm going to go down 1 and right 2. And since I want to be symmetric across this axis of symmetry, I'm also going to go down 1 and left 2. Creating my absolute value function that does open down and pass